Today you will spend roughly 35 minutes chewing, that is the whole of it, spread across breakfast, lunch, dinner, and whatever you eat standing at the fridge. A chimpanzee, with almost the same jaw muscles you have, spends 4.5 hours. An orangutan spends closer to 6.5. Every single day for its entire life. That is not a small difference. That is most of a working day spent chewing. And chimpanzees are not doing anything strange. They are doing what apes our size do, same jaws, different lives. We are the odd ones. Small teeth, weak jaws, short guts. By every measure of the ape body plan, we look like an animal that should struggle, and yet we run the most expensive brain of any primate that has ever existed. Something in our past broke the arithmetic every other great ape still lives inside. One researcher has spent 30 years arguing he knows exactly what it was, and that the evidence for it is almost entirely missing. This is the argument, and it is genuinely unresolved. Nobody has settled this. Start with the thing that has to be paid for. Your brain. It is about 2% of your body weight, and it is never off. At rest, it takes roughly a fifth of everything you burn. Some estimates say a quarter. That is an enormous standing bill for an organ that does no physical work. So the question in human evolution has never really been how our brains got clever. It is how our ancestors ever afforded to run them. The brain is expensive. In 1995, Leslie Aiello and Peter Wheeler put a name to the trade. They called it the expensive tissue hypothesis, and the idea is beautifully simple. Brains are costly, so are guts. A long digestive tract burns a lot of energy. If you shrink one, you free up the budget to grow the other. And across the primates, that is roughly what the numbers show. Smaller guts, bigger brains. Our own gut is noticeably shorter and simpler than a chimpanzee's, relative to our size. But shrinking your gut only works if your food gets easier to digest too. Otherwise, you have just made yourself worse at extracting energy from the same hard food. So something had to change on the plate before anything could change in the body. Food had to change first. And the fossils tell us roughly when it did. Around 1.9 million years ago, Homo erectus appears in the record. Bigger body, longer legs built for walking and running, and a brain jumping in size. By some measures, the brain size jumped from the species before it is over 40%. At the same time, the teeth get smaller, the jaw gets lighter, the rib cage narrows. That narrowing is the visible sign of a gut that is no longer an ape's gut. So here is a creature growing the most expensive tissue there is, while simultaneously dismantling the equipment for processing tough raw food. That should not work. It is like buying a bigger house and cutting your salary. Unless something outside the body started doing part of the digestive work instead, something changed on the plate. In 1997, a primatologist named Richard Wrangham was sitting in front of a fire. He was thinking about chimpanzees and about how hard their food is to eat, and he realized what an absurdly large difference a fire would make to that problem. His answer, later argued in full in his book Catching Fire, is a single word. Cooking. Not meat, not tools, not hunting. Cooking. That is the claim. Now, cooking does not add calories to food. People get this part wrong. A raw sweet potato and a cooked sweet potato contain the same chemical energy. What changes is how much of that energy your body can get out of it. Heat does two things, and both do work your gut would otherwise have to do. Starch, raw, is packed into tight crystalline granules your enzymes struggle to break into. Add water and heat, and those granules swell and burst open. That process is gelatinization. Suddenly the starch is exposed, and your amylase can get at nearly all of it. Protein does something similar. Raw, it is folded into tight resistant structures. Heat unravels those folds, which is denaturation, and your enzymes can reach the chain. The clearest everyday number is the egg. Cooked, an egg is over 90% digestible. Raw, that figure drops to somewhere between 50 and 60%. Same egg, same calories on the label. Nearly half of it walks straight through you. Same calories, different outcome. Cooking also softens food, which means less chewing and less energy spent chewing. That was the theory. And it stayed a theory, because nobody had measured it. Then in 2011, a Harvard graduate student named Rachel Carmody did. She built an experiment that sounds almost too simple to be a landmark. 2 groups of mice, 40 days, 2 foods, meat and sweet potato, each prepared 4 ways. Raw and whole, raw and pounded, cooked and whole, cooked and pounded. She controlled how much each mouse ate and how much it ran on its wheel. Then she measured what actually happened to their body mass. Cooked food delivered more usable energy than raw. For the meat and the sweet potato. And cooking beat pounding. Grinding food up helped a little. Heat helped considerably more. Mice on raw diets tended to lose weight. Mice on cooked diets held it. Cooked beat raw, every time. It was the first study to measure cooking's net energetic effect on a whole animal. And it has an awkward implication that has nothing to do with human evolution. The calorie numbers on food packaging come from a system built over a century ago. That system does not account for how much energy you spend digesting, or for the share your gut bacteria take before you ever see it. So the label on a raw food and a cooked food can read the same and simply not be. But there is a second argument, and it may be stronger than the energy one. It is not about calories at all. It is about hours. In 2012, Karina Fonseca Azevedo and Susana Herculano Hausel ran the numbers. They had already shown a brain's energy cost scales with its number of neurons, so they worked backwards. On a raw ape diet, how many hours would you need to feed to pay for a given body and a given number of brain neurons? For a gorilla, the answer comes out near 8.8 hours a day. For an orangutan, around 7.8. For a chimpanzee, around 7.3. Those numbers are close to what those animals genuinely do. The model matches reality. Then they ran a human brain. On raw food, it comes out above 9 hours a day, every day, just chewing and eating. Before hunting, walking, sleeping, or raising a child. There are not 9 spare hours in a day that also has to contain survival. There are not 9 hours. So raw food imposes a hard ceiling, and the great apes are sitting under it. They are large-bodied with modest brains because that is the only affordable combination. Cooking in this argument did not make bigger brains useful. It made them payable, which raises an obvious test. What happens to a modern human eating only raw food? We have an answer. From a study nobody designed for this purpose. In the 1990s, researchers at Gießen in Germany surveyed over 500 people who had been eating strict long-term raw diets, some of them for years. A substantial share of them had drifted below a normal healthy body weight. Among women under 45, around 30% reported disrupted or absent menstrual cycles, and that effect got stronger the closer their diet got to entirely raw. Raw was not enough. That last part is the evolutionarily important bit. It is a reproductive signal. And here is what makes it damning, rather than merely interesting. These were people in modern Germany, with blenders, food processors, and pressed oils. They could buy dense commercial fats that no forager could ever obtain. They were not walking 12 kilometers to find their dinner. They had every advantage, and a fully raw diet still could not reliably sustain them, which suggests that Homo sapiens is not merely fond of cooked food. We appear to be an animal that needs it. That is the argument's strongest leg. So, the anatomy fits, the energetics fit. The physiology of living people fits, and then you go looking for the fire, and the whole thing falls apart. Because if cooking drove the change at 1.9 million years ago, there should be hearths at 1.9 million years ago. There are not. There are no hearths. Fire is very hard to find archaeologically, and it is even harder to prove. Ash blows away. Charcoal rots. Burnt patches wash out in the first heavy season. And the deepest problem is telling a campfire from a lightning strike or a bushfire. A burnt bone is not evidence of cooking. It is evidence a bone got hot. In 2011, Roebroeks and Villa went at this systematically. They built a database of well over 100 possible fire sites across Europe, spanning from more than 1 million years ago down to 35,000, and graded every one of them by how confident the evidence actually was. Their conclusion was not what most archaeologists expected. Habitual use of fire in Europe only shows up from about 400,000 years ago. Before that, the evidence is thin, scattered, and mostly ambiguous. And that produces a genuinely startling implication about how Europe was settled. Early hominins walked into northern latitudes, into winters that dropped below freezing, apparently without habitual fire. Most researchers had assumed that was impossible. So now look at the size of the gap the cooking hypothesis has to explain. The anatomical change is at 1.9 million years ago. The solid, uncontested fire record starts around 400,000. That is 1.5 million years of missing evidence. 1.5 million years. That is not a detail. That is the biggest objection, and it is serious. There are only 2 ways out of it, and researchers are split between them. The first, fire is far older than we can see, and the record has not survived. The second, something other than cooking paid for those bodies and brains. And there is a real candidate for that second option. Aiello and Wheeler themselves favored energy-dense animal foods rather than heat. Marrow, brain tissue, organ meat, soft, calorie-rich, and available without any fire at all. A separate line of work points at stone tools instead of heat. Slicing meat and pounding roots with simple flakes makes food dramatically easier to chew. One Harvard study estimated the saving at millions of chews a year. That alone might explain smaller teeth and lighter jaws, with no fire required. Wrangham's counter is that these effects are real but too small for a change this size. He has also pointed out that early Homo already had weak jaws and small teeth, which makes a fully raw diet hard to explain whichever processing method you prefer. He has said plainly that no solution is currently satisfactory. That is fair. No solution is satisfactory. But the fire record has one clear direction of travel. It keeps getting older. In 2012, a team led by Francesco Berna published a result from South Africa. Wonderwerk Cave, near the edge of the Kalahari, with a very deep occupation sequence. They sampled sediment from a layer around 1 million years old, and critically, they sampled it more than 30 meters in from the cave entrance. That distance matters more than almost anything else in the finding. 30 meters inside, wind cannot blow ash in. Rain cannot wash debris that far. A bushfire outside does not deposit a burnt layer deep inside a cave. Using microscopic and infrared analysis, they found ashed plant material and burnt bone, burnt in place rather than carried in. Alongside stone tools and heat-fractured flakes, it was widely reported as the earliest secure evidence for controlled fire. And the work at that site has continued, using a genuinely elegant technique. Bone that has been heated changes its crystal structure at the mineral level. Shine a narrow blue light on it, view it through a red filter, and heated bone glows. Bone that was never heated does not. Chemistry alone had been ambiguous. Recent work applying this at Wonderwerk points to burning considerably older than 1,000,000 years. That is new, and has not been argued over properly yet. Treated as promising, not settled. Fire is not cooking. Fire proves heat. It does not prove a meal. Those are different claims. For that, you want food that was heated deliberately and heated carefully. Which brings us to a lake in northern Israel, 780,000 years ago. The site is Gesher Beno Yaakov, on the shore of a lake that no longer exists. It is waterlogged, which is why organic materials survive there at all. Excavators recovered more than 40,000 fish remains from the deposits, and the assemblage had a very strange shape to it. In the layers where hominins had been active, the fish bones were almost entirely absent, but the pharyngeal teeth, the hard grinding teeth in the fish's throat, were everywhere. Over 95% of what survived was teeth, clustered around traces of hearths. That is what you get when bone disintegrates and only the hardest part remains. So the team ran X-ray diffraction on the teeth to read the crystal structure. The teeth had been heated, but heated below 500 degrees. That number is the whole finding. That is not a fish that fell in a fire. Burning something to ash is easy. Heating a fish gently enough to cook it is a controlled act, and it points at intent rather than accident. 2 species of large carp, chosen preferentially, cooked at low temperature, eaten on site. Published in 2022, it is currently the earliest evidence of hominins cooking a meal, the earliest known meal, 780,000 years ago. Still nowhere near 1.9 million. But there is one more distinction worth making, because it is easy to miss. Using fire and making fire are not the same skill, and a long time separates them. For most of this story, hominins were probably harvesting fire rather than starting it. Lightning strikes, a grass fire. You take a burning branch and you keep it alive. Keeping a fire lit is a real skill, and a completely different one from lighting it. Recent work at a site called Wrangham in Suffolk, England, pushes at that boundary directly. On a 400,000-year-old buried land surface, researchers found baked sediment, heat-shattered flint hand axes, and fragments of pyrite that do not occur naturally at that spot. Pyrite struck against flint throws sparks. Somebody appears to have carried it there. That is not evidence of using fire. That is evidence of deciding to make one. Using fire. Making fire. So where does all of this actually leave the question? The honest answer is that the cooking hypothesis is not proven and may not be provable. What is not in dispute is the outcome, whatever the cause turns out to be. A chimpanzee spends half its waking life chewing. You spent 35 minutes. Somewhere in the last 2 million years, our ancestors bought back most of a day. Every tool and every story has been paid for with those hours, including this one.